Yeah, welcome to our talk. Today we would like to talk a bit more about some things we don't show here in the exhibition, but things we can talk about more in detail in a talk like that. Yeah, as you said, that's us. Okay, to keep it short, I'm a game designer and he's an animation filmmaker. Together we worked on the project, and also we talk about this project now a bit from these perspectives. Together we also have a small production company called Playables.
Yes, and we have 100 slides, as I see, just as an information. I know it's gonna go quickly. So yeah, kids, we're not gonna talk much about the project itself as the form it takes, because like as the exhibition already explains, it's an app we make for smartphones and desktop computers. We also work on a film, an animated short film, and the last icon represents this very exhibition here. So these are kind of the three pillars. Today we're going to talk about the thing that drives this project, and this is like the animation and the code, or better, the relationship between the animation and the code. Because it's, it's like every relationship, it's tricky. It starts, or also the project started like that. I started drawing animations. So here you see like animations that I started at the very beginning of the project. So it's just a frame-by-frame animation, classical 2D, hand-drawn. Here it's like, 12 frames per second. In the final project it's 24 frames per second. And then I go with these assets, sit together with Mario, and we try to make something interesting with code. And this was like the first prototype we made together. So as I said, this relationship is not always easy. And so today we're going to talk about what made that relationship sometimes difficult, and why we finally decided to also develop our own animation system for that project. And we're gonna illustrate that by showing 3 problems we had, or we kind of discovered while working on the project. The first one is a very obvious one. It's like, while working with 2D hand-drawn animation, this is quite a static thing, 2D animation. So you have keyframes and you plan down your animation, and when you play it, it always plays it the same way. So it's not dynamic at all. And in a game you want to have responsiveness, you want to have a dynamic way to play this animation, and this was like one of the reasons why to do the animation system our own.
So our idea was to, instead of just playing the animations, to find a way how we could make everything move smoothly and react on inputs of the user. And one big thing we noticed also in previous project is that you have to work quite differently if you don't know if somebody will just stop, for example, somebody walking immediately after starting to click somewhere, to move somewhere. So it's you never know what will happen in the future, so you can't say this animation will play until the end and then you'll see what will happen. Another thing when working with animation is that it gets easily very complicated, and especially when using tools like Unity, what we use for kids, a game engine, there are often tools integrated in these tools already, but it can easily look like this, and especially often in these cases it's like in the case of Unity, it's really made for 3D animation, and it supports 2D animation, but it's really not easy to work with, and it's really hard to control what's happening. So like maybe a system like that, which at the end is maybe complicated but works well for 3D with blending animations or moving things smoothly. It just didn't work for us, or like we needed something where we have more precise control over what's happening. And another reason why we started to think about our own system to do the animation is exactly this, what you see here. It's very annoying to look at it. And the thing that happens here is something that happens very quickly when you use an animation system like one that is made for 3D animations, which are not frame by frame. The problem here is that the updates of these different characters are not at the same time. This is never a problem if you have smooth animations with animation curves, but it's a problem if you have 24 frames per second on a screen that updates with 60 frames per second. And this was a surprisingly hard problem at the beginning to understand why this even happens. And yeah, for us it was important that it's smooth and everything, basically like an animated film, gets updated at the same time. To see next to each other, that's, yeah, how is the difference looking. So these are a few problems that we understood during the process. It's out of sync. We wanted to have it in sync with each other. It should be also a bit more compact in terms of working with 2D animation. For example, we wanted to have animations that go in different directions, how to work with that in a tool like we have provided, for example, in Unity. And also we wanted to have something very dynamic, so for example, you don't have to wait for animations to finish, and something you can really control very precisely how it works.
So this is the group therapy between animation and code. You make prototypes, you figure out what is not working, you change your workflow, you go back to prototyping, and you go on until you finally figured out how to do the workflow. And now we're going to talk about the workflow, like how do we go from drawing animations to import the assets into the game engine, and how do we go from there. So it's going to be very technical now, but very easy to understand, of course. That's how I start. Like, I have some idea of what I want to animate and how it should work. So here I have 2 characters. I will split this in 2 animations. So I need one animation of a character hitting and going back in the original state. So it's just standing, hitting, standing. So this is what I do. I draw a keyframe, have an action frame, and I animate the stuff in between. And we also, that's very important, something that when I made animations myself for films, it was not so important how things are named. And in our system, it's super crucial how things are named. So the system we have is always that for every animation, there's the name of the key, the name of the action, and then again the name of the key. So this animation is going in a direction also, because everything in our kits works on an orthographic stage on 4 axes. So I put it on this grid and draw 5 other axes, and 3 of them I'm able to mirror. So like that. And that's like a snippet of animation that is then completed. So if you look at it as a flow chart, this is the hit animation. And so the second part here is someone being hit, so knocked over. So that's going to be like the second animation I plan. So here I have a new keyframe, the lie keyframe. So I have a stand keyframe, I have a lie keyframe. I, of course, then animate the stuff in between. And that's how the animation looks like. Now here the speciality about this one, or the difference between the last one, is that the character is moving in space. So it's not just standing still. And this information is very important to have when importing the animation to an engine, to have this information. So what we do, we draw a separate layer in the animation with just a small point that is like projected to the floor to have the information where the character is located. So this is going to be important for physics calculations, but also just for the camera to know where to look at if I follow a character. So this is this separate layer of this, we call them pivot points. That's just the position information. And to use that for the animation process, we developed a small tool, online tool, where we can import these pivot point informations on the 0 axis, and it generates all the other axes. And I can use then this image to lay out all the other axes I have to animate. So this is the 0 axis, and all the others follow. So what we have now is this animation here completed. So someone hitting and someone being hit, and this is how it looks combined. This, of course, is not a finished loop. So the hit loop goes back to the stand position, to the idle position. The knockover loop is just lying there. So what you have to have is then like to think about can I get back to the standing position, and that's kind of how we build up our whole action system. So it's like what the characters can do. There are a lot of like pointing, for example, is a totally different system that we used, but we're not going to go in these details now, because these are just the actions. After we're going to talk about movement, locomotion, that functions a little bit differently. So from there, I then export the animation as just as a sequence of images. And this is how that looks like. So the body and the shadow is in a different layer. And on the 0 axis, there is the pivot folder that has the information of the displacement of the character inside. And this folder I then give over to Mario to continue.
And let's go to the computer. So I will get these files from him, and it was often working, but sometimes also it didn't. So I had to check these files, like if everything's there, like especially these points, if they're all there in the right order. And at some point I understand that actually everything is okay. And
yeah, but maybe I can talk about the white space.
So I will. The thing is that it's a bit annoying to work with these huge images, even if they're only very small. If you look at the content, because we have a lot of white space or empty space around the animations, so we have enough space, for example, to do movement. So before importing, I have to use this tool that creates these. Like the animations, how I actually import them into the game, which are cropped images with a text-based metadata file with just the information about where this point is, so I don't have to do it inside Unity itself. And in there it looks like this, that I have this same list of files, which I then can play them back, because it's this animation is automatically created from the names of like how we named the animation. So at the end, it's a very different way than how you might do it manually. The thing is, we have I don't know, 2,000 or 3,000 animation files, pictures. So if we would have to move them manually around, it would be really annoying. And instead, we just used a simple animation naming system to do that. And now about one thing that is actually was not shown yet, we have a lot of, in kids, a lot of movement. So the characters move around, they don't just do actions, they move from point A to point B. So not an easy problem is to do that nicely, because at the same, like we said at the beginning, we have our 2D animation frame by frame, and we can't really just let's say slow them down because everything has to be synchronized. So we can't just say, okay, if you walk slowly, we'll just play the animation more slowly.
So what we try is to split all the animation into the smallest part possible. So we have like as here we have a standing position. We have then like a walk loop as well as a loop to run, and every step is like a separate animation. So you don't even do a double step or something, and so this is working everything on this 4 axis that I showed before. The reason for that is now we can really change direction on every frame. So this is why it was important to animate everything on the exact calculated point in space.
So there's still this question how to move from point A to point B, because we have this system of animations, but how to go through them, how to know which steps have to be played to get from here to there. So this is not, there is no like clear solution for that. It was just a way how we worked with that, because we had to figure out different things, and for our case it worked very well to do it like that. So that's how it looks at the end. So the idea is that this character runs when there is enough space to run, and then slow down smoothly to stop. But the character will not start to run if there is not enough space to stop smoothly. So basically, if the character wants to go a few steps, then it will never start to run. But on the other hand, if the target is far away, the character will start to run and keep running until it is close enough. And this is very important. It is very important to decide these things very often, which is each step in our case, because at any point it could happen that the target point, which is now this red circle, which is an object that gets simulated through physics, it can change at every point the direction or the position. So we have to check very often, like what could we do next to make a smooth step possible. So this looks maybe a bit scary, but it's a graph of, or it's a way to visualize this, where you have the distance, like this character wants to go from here to there, and it has some speed, which is walk, like here it is standing and there it is walking. So a simple walk from here to there would look like this. So the animation standing to walking would be played, then one step from the right step to the left step, then another step, and then back to the standing position. But what actually happens is that the system doesn't decide at the beginning what will happen, but actually it happens at every step, that the character will understand, can I keep my speed to get there, or do I have to slow down to stop smoothly? So this happens at every step, and at this point now, the character understands that actually there is not enough space to do one more step and then stop, so I have to stop right now. So if you look at the same thing when we have to do a smaller distance, then it will look something like that. And in the shortest case, it's just like the character would start to walk and then stop again. Also, what we soon understood is if the characters always have to do a full step, then they walk quite far already, because a step to start and to stop again is already quite a distance in the scene. So we needed to have some kind of way what to do when there has to be only done a small step. And instead of starting to walk, there is a thing called a small step or a tiny step, which just reacts to that. In case the character only has to go next to it, like only a very small distance, then it will do that. So that's the general idea how it works. So each step, actually the next step is decided, and this makes it possible to always run the steps in the right order after each other without sliding around too much, except there are different directions which are not animated. But actually, the thing is that there is also this additional thing called run. So if the characters want to go far, it's even a bit more complicated. Then it looks like this. The character thinks about, can I actually get faster and still arrive at the point where I want to go? And if this is okay, then the character will start to accelerate. And the same thing happens again. There is no more room to accelerate, but to either keep the speed or slow down. And this will be done until there is no more space to keep the speed. But at this point here, for example, the character could theoretically, if the target would move away very quickly again during this step, during the slowdown, it could actually also start to run again. So that's the full loop, what happens when you walk around. And for one character, it's easy to program this in a way, but the interesting thing at the end is that it also works when you have bigger crowds. So if all of them do one step or two steps, of course there are some details which look differently, but the idea is that because we only have one object in the game or in this world, we can actually focus all our attention in making this one thing work well.
Yeah, that's our love story between animation and code. That's, I think, almost everything we said. So I hope it was not too abstract. If it was too abstract, please go out and look at the stuff. There you can just touch it and it should work. What I also want to mention, today we really tried to focus on how the animation works with the code. But there is like the other thing that is as important as the animation. It's the sound, the audio. And we're actually going to have another talk next Monday, I think, here at the ZHDK, about how we implement the sound and how we went about that. Yes, the game is about to release this year, and this is its website. And now we can have questions or beer or wine or or whatever. Thanks for listening and coming today.